So here's another method of factoring. This one is called factoring in the box. And it works really well with trinomials of the version ax squared plus bx plus c, where a is greater than 1. And first, of course, I look to see, can I factor out a greatest common factor? And no, 17's prime. My 14 doesn't have an x, so there's no common factor I can factor out. Then I'm going to set it up in a box. So I'm going to just draw myself a little box here. The first term goes in this upper left corner box. The last term goes in the lower right corner of the box. So the A goes there, and the C goes there, and then I multiply A times C. So in that case, I'm going to multiply 6 times negative 14. That'll give me negative 84. I'm going to find factors of 84. I will worry about the negative after I figure out my pairs of factors that multiply to 84. I always do this systematically so that I know I have all of the factors. Otherwise, I'm guessing and checking, and I'm trying to remember, well, which ones have I tried and which ones haven't I tried, and it gets frustrating. If I keep them in order and very systematically go through and find all the pairs of factors of 84, I know which ones to check. I know I have them all. 7, I'm looking, 8, won't, 9, 10, 11 don't. So I know that I've got all my pairs of factors of 84. I didn't worry about the negative because right here, because it's negative, I know I need the difference between my pairs of factors to be positive 17, because my middle term, my b term, is positive 17. So come right down here and I find 4 and 21. The difference between 4 and 21 is 17. So I'm going to have a positive 21 and a negative 4. It doesn't really matter which box I put these in, as long as I put in negative 4 and positive 21. And yes, they're each going to have an x with them because negative 4x plus 21x gives me positive 17x. And that's what I'm after. Next comes the reason the box is here. I'm going to factor out the greatest common factor in each column. So I'm going to factor out my greatest common factor there. That's going to be, looks like 21 and 6. 3 will go into both of those, and an x. I don't even have to worry about what's left over. I just need the greatest common factor. And then I'm going to factor out the greatest common factor for between negative 4x and negative 14. Because the top box has a negative in, it's going to be a minus here, negative. And I'm going to factor out a negative 2. And then I'm going to leave that there for just a minute. And I'm going to factor out my greatest common factors in the rows. And in this first row, I can factor out a 2x. In the second row, I can factor out a 7. Because the first term here is positive, it's going to be plus between them. So my factors are 3x minus 2 times 2x plus 7. So this is this one factor. This is the other factor. And of course, I want to check this and make sure it gives me back my original trinomial. So I'm going to expand it out. 3x times 2x is 6x squared. 3x times 7 is positive 21x. Negative 2 times 2x is negative 4x. And negative 2 times positive 7 is negative 14. When I combine these like terms, I get 6x squared plus 17x minus 14, which is my original polynomial right here. So this is my solution. I hope this helps.